Good morning, students. Our today's topic in the topic of periodic table is Group O or 8 noble gases. And here are noble gases: helium, neon, argon, krypton, xenon, and radon. All elements except helium in this group have 8 valence electrons. So here is the electronic configuration. They are having outermost shell complete. So that's why they are called noble gases. They are unreactive. They are all colorless monoatomic one atom gases at room temperature. So this is the point which you people required to remember. They are normally one atom gases at room temperature. There is a very narrow temperature range over which any one of them can exist as a liquid. So they normally go from a solid to gas, and there is a very narrow range in which they become a liquid. They are unreactive because atoms of the noble gases possess fully filled outermost electrons, shell or stable octet configuration. This is also because of their high ionization energy. And here is a very interesting cartoon that represents this quality of theirs. So look now, a waiter is asking from neon, "Sir, do you want more electrons?" So the neon's answer is, "No, thanks, I am full," because neon is having outermost shell complete. So that's why they are unreactive. Uses of the noble gases. Helium is used to fill airships and balloons to prevent incidents of fire because helium is unreactive. So that's why it is used in the airships and balloons to prevent incidents of fire. Neon is used in the neon signs. Argon and neons are used in the light bulbs to prevent oxidation of the filaments, and argon is used in the manufacture of the steel to prevent the oxidation of the steel. Here are some physical properties of the noble gases, and if you look closely, the melting point of helium is 1.1 and the boiling point is 4.2. So you can see the very narrow range in which they occur in the form of the liquid. So look at the melting and boiling points difference. There is very narrow range of the temperature in which they become a liquid. Okay, the boiling points. The forces between the molecules get stronger as the molecules get large. The boiling points or the boiling temperature of the noble gases increases as we go down the group. So point to remember is, as you go down the group in group 0 or group 8, the boiling point of the noble gases increases. Okay, here is the graph. So look now, helium is having the highest boiling point as the others. Okay, next thing that we are going to read is the densities. The density of the noble gases increase as we go down the group. So this is the graph. So the boiling point and densities increases as we go down the group in group 8. Next thing that we are going to read is the chemistry at work. Actually, we are going to read their uses, group 8's elements uses. First, we are going to read the uses of the helium. If we cool down the metals to very low temperature, they lose their electrical resistance. They become perfect conductors or superconductors. Liquid helium is used to cool metals down. So this is the first use of the group 8 metals, particularly helium. Helium is used to cool down the metals. Helium boils at -269 degrees C. It is used to cool down the coils in body scanners in hospitals. The coils can then make the very strong magnetic field that scanners need. These machines have become very important. Doctors can now see a complete picture of the organs inside your body. So if you can see, the doctor is seeing inside your skull. This is very useful in finding cancer and helps doctors to judge what effect their treatment is having on the tumors. Have you ever seen an airship perhaps at a sporting event. So you can see in football big tournaments and cricket tournaments, the airships normally are there in the ground, from which you can have the aerial view of the ground. So look now, cameras on board provide those fantastic views looking down on the arena and crowds. But now the most important, the most modern technologies using in these kinds of the events, that is called drone. So, some years before, the airships were used. As you know, helium is much less than air. It is used to fill the airships to provide lift. So, this is another use. Helium is much less dense than the air. That's why it is used to give uplift to the airships. Next, we are going to read the uses of the neon. Late in the 1800s, scientists were investigating gases and electricity. They found that a gas at low pressure can be made to glow if we apply a high voltage to it. These discharge tubes helped scientists like J.J. Thomson in finding out more about electrons and atoms. So the more simple is, look here, nowadays we use the noble gases to make many of the brightly colored lights you see in the cities. So as you pass through any main road of your city, you can see different neon signs with different colors, yellow, red, blue, etc. So these are actually neon gases. Neon is the gas used for red signs. So here you can see Coca-Cola board. So here is neon gases used, which is giving red color to it. Next, we are going to read the uses of the argon. Light bulbs are filled with argon gas. Argon won't react with the tungsten metal filament inside the bulb, even when it is white hot. It lacks of the reactivity, also helps in welding. So look here, it acts as a shield around the hot metal in the weld. So it is used in welding and it is used in the light bulbs. It is also used in the extraction of the titanium metal. We also pump the gas into the molten mixture to stir it up when making steel. Okay, next we are going to read some uses of the krypton. Krypton gas is in the laser that doctors use to operate on eyes in repairing the retinas. So this krypton gas is used. The laser opposite is being used to repair the retina at the back of the eye. Next, we are going to read the uses of the radon. In rocks such as granite, they are small amount of naturally occurring radium. This radioactive element breaks down into radon gas, which is itself radioactive. So the gas can build up and become a danger to health because this is radioactive. Ironically, radon is used to help treat cancer. So these are the uses of the radon gas. So this was the lecture, students. Read this lecture again, understand it, learn it, and make your notes. Thank you so much.